Hi, my name is Sai Harshvardhan Maduna. Today we are going to discuss about the deep learning lesson 5. In this lesson we have learned basics of LSTM, types of RNN and the use case like sentimental analysis and Twitter data, form data dataset. Coming to the in-class programming, the first one we have to do is save the model and use the saved model to predict the new text data. For example, a lot of good things are happening. We are respected again throughout the world, and that's a great thing. A real Donald Trump. This is the tweet tweeted by the Donald Trump, and this one we are going to get the sensitive sentiment, and we are going to do the sentiment analysis on this. We for that we are going to save the model, and we are going to use the same model to predict it. Coming to the code, here is the import functions, import libraries we have imported in the history, and then we are going to import the segment.csv. In this csv, all the data in all the columns, all the data to predict which word is positive, which word is negative, all the data will be there. And with this segment csv, we are going to convert the text and make it and save and keep the necessary columns which into the data. And then we are going to if the data is a positive, we are going to size dot positive. If it is a negative, and we are going to print it as a negative. Yeah, for this we are for this we are the features as 2000, and a tokenizer splitting all the words with the space, and the tokenization was done and fit the values in the text. And after that we are going to do the padding. And padding means it's making everything in the same length, and these after adding these padding sequences, we are going to print that. After that we are going to create the model yeah, with the sequential model. And with the help of sequential model, we are going to create a model, and then we are going to add the dense layers with two neurons and activation of a softmax. And uh, after that we start encoding the we start using the label encoder to encode it, and starting and get the x train, y train, x test and y test data. And we are going to use those data and print them train shape, x train shape and x y train shape, training data, and test data of x and y shapes. After that we are going to create the model, and we are going to fit those x and y train data into this particular model in the with the epochs of 5. Once it is fitted, and we are going to print the score. After that we have created a JSON model. In this JSON model we are going to serialize the weights into this JSON is a model.json. And this after that we are going to serialize the weights to the hdfi using .h5 model.h5. And then we will save this model, and that's JSON file. And this JSON file, open the JSON file, and we are going to read the JSON file using .read function, and going to close the file. And then we will load the file, and after with and loading those weights from the model.h5, which we got saved that model, and then we will print that. After that we are going to take that tweet data, which we are going to analyze, and this tweet data will be sent to this particular function, tokenizer text dot sequences. And these sequences, after sending this data, it will do the padding, and this padding makes the same size and the same shape. And then it will print the tweet, and it will predict the it will do the sentiment analysis. In the sentiment analysis, it gives the output, either it's a positive or it's a negative, how much positive the tweet is or how much negative the tweet is. Here we are going to get the encoded tweet like 0000 or 7 like, and these values, and all the epochs, 5 epochs were run and calculated the accuracy, and final positive is 0.47, and negative is 0.52. Coming to the second program, here we are going to do the applying the grid search CV on the source code provided in the class. We have seen the grid search CV in the PPT, which Ms. Saria has explained, and that before that we are going to import all the libraries, and then we will do the pre-processing using label encoder, and the same sentiment CSV we have used for this, and then we have created the model. Before that we will use the padding sequences, make the data same, and then we started adding the layers, dense layers, and final output layer with the tune neurons and the activation as softmax, and then we are going to encode using label encoder and transform the and fit that and transform the segment with the fit transform function, and we are going to get the values of x train, x test, y train, and white test. Use here we are going to use the Keras classifier, and with the two epochs 1 and 2, and then we are going to get the by using this, after that we are going to give this model to the grid search CSV, grid search CV, and then we will print the results, and this grid dot fit, in this particular grid we are going to fit the x train data and y train data with the batch size of 32, and we are going to print the data. Here you can see the grid search CV, and the best uh, the best accuracy we best scores we got is 0.85, that's 85%, and with the epochs of 2 we can increase the epochs. And coming to the third code, apply the code on the spam on spam data set available in the source code. Here we are going to apply the data code. We are going to apply the code on the spam data set. Till now we have used both sentiment.csv. We are going to use the spam data set, and visualizing the and in the bonus we are going to visualize the, oh, okay. Coming to the third program, we are going to import that all the functions imports at the starting of the program, and then we will read the spam.csv, and we are going to since it has a ham as a first column, and spam with the second column, we are going to replace all with zeros and ones, and it has the total hams of zeros, and total spam messages as 1, and then these after using total we are going to get the original messages here, and we are going to use the regex, that is regular expressions, by replacing email address with the email header, http url address with the http header, and money symbols with the money symbol, and phone numbers with the phone number, and numbers with number, and using these codes we are going to use the we are going to apply the model. Here we in this particular code bit of code, we are going to remove all the punctuations, and we are going to remove all the punctuations, and we are going to get the data. Here each word to the we are going to convert each word to the lowercase, and splitting words to tokenize. After that we are going to use the stemming with the porter stemmer porter stemmer, and handling the stop words. After that we are going to prepare the messages with the remaining tokens. These after preparing word tokens with the corpus, here we are going to append the all messages using the corpus dot append function, and then we are going to encode the data using label encoder, and transform the data, and the using lee dot fit transform. The X train, Y train, and X test, Y test are used in this using count vectorizer as a CB, and we are going to transform the corpus, and we are going to put the label encoder to encode the message, and then we are going to get the train, X test, and Y test. After that, we started using a Gaussian NB or classifier, using base classifier as a Gaussian NB, and we are going to get fix the data, the what are the data we have in the X train and Y train. We are going to use it, and we are going to predict the base predict the Y using base classifier by giving the X test as a input value, and we are going to evaluate the confusion matrix with all Y test and Y predicted values. Here we are going to put the we are going to print the accuracy score and the classification report with the predicted test. Here you can see the split messages and the streaming messages in the result. Here the accuracy we have printed for as a 0.8787, that is 87%, and this is the confusion matrix which was printed. Thank you.